how to draw the principal rays for concave and convex mirrors. So concave mirrors are a little more complex, so we're going to start with those. So you draw your mirror, draw your focal distance, which is here in this diagram. I put a little F underneath it. Draw the radius of curvature, which is usually twice the focal distance, out here. And then place your object wherever it's supposed to be along the x-axis here. I put it here, which is about a third again as far from the radius. So we usually use an arrow for the object, but you can really draw anything you want. And we start from the top of the object, and we draw a ray coming in parallel to the x-axis. That ray will be reflected down through the focus. If, and we need to be careful here, the object is on the far side of the focus. So the ray comes in parallel, gets reflected down through the focus. A second ray does the opposite. That ray comes from the top of the object, goes through the focus, and is reflected out parallel. And finally, the third ray goes through the radius of curvature, hits the mirror, and gets bounced back out through the radius of curvature. Where those rays intersect is where your real object will be. This is a real object because, again, if you put a piece of paper here, an image would be reflected from the mirror onto the paper, and you would see a little arrow on that piece of paper. All right, now this is only true if the object is outside the focus. If the object is inside the focus or between the focus and the mirror, things get a little more complex. So here we've drawn our arrow here, our object here, and we draw the first ray. Now the first ray is supposed to go through the focus, but we have to be a little creative here because we're inside the focus. So we draw a ray that, if it had started down here, would have gone through the focus, goes to the top and hits the mirror. So basically you draw a line that is angled such that, here's the line here, the extension of that line goes down through the focus here. So goes in, bounces out parallel. Secondly, you then draw a line that goes in horizontally, and that one gets bounced through the focus. And then finally, and again, this is kind of imagineering a little bit here, we draw a line that would have gone through the radius, but it starts at the top, goes out here, hits the mirror, comes back down, and on its way out again goes through the radius. So you have these three little lines here, and you extend them back using dotted lines on the other side of the mirror. And where those dotted lines meet is your object. In this particular case, you see the object is actually bigger. Or sorry, is your mirror, is your image. And in this case, the image is actually bigger than the object. And it is a virtual image because it is on the other side of the mirror. Now finally, convex mirrors are a little less complex. They only produce virtual objects, and they are always on the other side of the mirror, and I believe they always kind of shrink the image relative to the object. But we try and do the same thing we did up here. We draw a line from the top of the object that would go through the focus if the mirror didn't reflect it. So it goes down here, and it would have hit the focus, but it doesn't. So it's a line that's pointed towards the focus, and that gets reflected out parallel to the x-axis. Another line goes from the top, another ray goes and hits the mirror, and if it had gone on past that, it would have hit the radius of curvature, but it doesn't. But that one goes in and then it goes out again along the same line. And finally, the third ray goes in parallel, and it is reflected off in such a way that that line would have gone through the focus, or it's as if the ray began at the focus and went out along that line. So goes in parallel, goes out along a line that can be extended back to the focus. And where those extensions meet, you can draw your dotted lines in here, boop, 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 and that one there. And you can draw the top of your arrow there. And you can see that obviously this object is much bigger than this image.